So tonight, I think it's suitable that we have a discussion about life. Life on Earth, life in space, human life, artificial life, synthetic life, the origin of life, the secret of life, the meaning of life. I'd like to get on to extraterrestrial life because I think potentially that's the most extraordinary discovery that we will yet make, and maybe we will. But you wouldn't necessarily expect to find that it had DNA. You might find it had something else. And a lot of the properties of the genetic code look like what I think Francis Crick called a frozen accident. In other words, that it could have been a different group of bases that came together to spell out a code. You could even imagine completely different sequences of things on DNA.
Whenever I meet a biochemist, I always try to persuade them to try to dream up an alternative biochemistry, an alternative genetics. I mean, we are so used to the idea that you have DNA programming the sequence of amino acids making proteins. And it may be that that's the only way it would work. It wouldn't necessarily be the same genetic code. As Francis Crick said, that almost certainly is a frozen accident. But it does look, doesn't it, as though protein has got some very, very important properties that might have to be universal. As I understand it, what the important property of protein is that the one-dimensional sequence of amino acids, which in turn is specified by the one-dimensional sequence of the genetic code, the one-dimensional sequence of amino acids determines how the protein chain shall wrap itself up into a knot, which has a three-dimensional shape. And that three-dimensional shape is absolutely crucial for governing, controlling, by its enzymatic properties, governing and controlling the chemistry of the cell. And I think I'm right in saying that a protein is capable of coiling itself up into almost any shape you like, if only you could think up the right sequence of amino acids. And so, since it's three-dimensional shape that determines the catalytic properties of an enzyme, then you've only got to have the one-dimensional code to specify the one-dimensional sequence of amino acids to make the three-dimensional shape, which will then have the desired biochemical effect. Well, that's a very, very singular property of protein, and it may be that...
Doesn't RNA have that property?
It does, yes, and that's in a rather weak, attenuated form.
Yeah.
And that gives a possible clue as to how the whole process got started. Because, as you know, people have talked about the catch-22 of the origin of life. You've got to have something like protein to do the catalytic function. But you've got to have something like DNA to do the replication and the specification of the protein sequence, because protein cannot copy itself. Right. And I think the reason for that is that it is wrapped up in three-dimensional shape. Yes. And therefore, the one-dimensional sequence of amino acids is therefore inaccessible, because it's buried deep within the knot. So you've got to have something like DNA, something like protein, and how do you get one without the other? And the answer may be RNA.
This was one of the great bafflements before the discovery of the double helix, was essentially realizing that life had three-dimensional properties.
Yes.
And yet three-dimensional things can't copy themselves.
Yes.
You know, you can't, there are no three-dimensional photocopiers, as it were. I think that brings us neatly onto synthetic life, because just recently Craig Venter unveiled Synthia, which was the cell of a bacterium into which he had put a completely de novo genetic code that he had synthesized, and it was able to function and to reproduce. When I say de novo, he had actually taken the instructions for building the thing from another organism. So it was not that he had designed each gene himself, he had simply copied, but he'd synthesized them. My reaction was that I was neither terribly impressed by the potential applications yet, nor terribly worried by the potential implications yet. As I put it, the chances of this thing going out and running amok was the chances of a tricycle going berserk on the M1. You know, God is out, I mean, nature is out there testing thousands of designs every day. Is that your reaction, or
Yeah,
am I
guess.
being unimaginative?
I'm reminded of Sidney Brenner's a few years ago saying, keep the lid on the Petri dish well screwed down. I mean, I sort of picture, I know this isn't actually how it happened, but I picture Craig Venter sitting at a keyboard typing A, G, T, C,
Yes.
G, A, C, G, G, and the machine at the other end of the typewriter plonking these things one after another and making the genome. I mean, it sort of was like that. But as you say, the genome that he wasn't actually typing, but the genome that he was synthesizing did come from an existing. It was already known. It's as though it was typed from a computer disk rather than from a.
And I don't want to detract from the achievement, because it was an incredible technical achievement, and all sorts of obstacles came up that they didn't expect, and that the workarounds turned out to be interesting, etc. And I think and it's possible that this might be a wonderful route towards the restoration of extinct species.
It could be that. As you say, you could imagine getting extinct species, getting a mammoth, getting woolly rhinoceros, getting a Neanderthal man. After all, 60% of the Neanderthal genome has now been sequenced by Svante Pääbo's team almost in the same week as the announcement of Craig Venter's achievement. So that the Venter achievement seems to me to open the way to doing the same thing, not on bacteria, but on maybe Neanderthal. I mean, you'd have to find a woman to volunteer to give birth to it.
Yes.
But woolly mammoth, similarly, the genome is pretty much done now, and you could implant that in an elephant. So I do think that it's just the beginning. That the tricycle, is going to mature. I think
it's going to be more than a tricycle.
That could be a scary prospect to some people.
Yeah, and the phrase artificial life is not the same as synthetic life. And synthetic life is what we've just been talking about. Artificial life, in a way, is sort of software versions of life, which, in a way, you invented. I mean, some of these you set computer programs going so that shapes on a computer would evolve by natural selection.
Yes, that's in The Blind Watchmaker and Climbing Mount Improbable. Some of it would be actual robots that run around the floor and do lifelike things. Others never leave the computer screen, but that's not much less interesting.
And is there a point where you could describe that as being alive? I mean, are we going to see in your or my lifetime computer programs and or machines that you would describe as alive?
Well, I think they would have to be capable of reproduction, really coming into the very first point you made this evening. And that's technically difficult to do. It would be a lot easier to do on a computer screen. So if you simulate in a computer a complete simulated world, a virtual world, in which there's a virtual physics, in which things move around in a virtual three-dimensional space, and that's been done. So you can have a constructed world which the human views on a computer screen, maybe with goggles to give it a 3D, give it a stereo effect. Now, those, of course, can reproduce. And I think the most interesting pioneering effort of that is Steve Grand and his program called Creatures, where you have these rather Disneyfied little creatures who walk around a computer world. There's a real physics. I mean, they fall and they bump into things and they go around things. They have genes. They reproduce. The genes determine their bodily attributes, their phenotypes. They have sex. They reproduce, and they evolve, and they learn. And so, provided you don't mind being constrained to be within the world of a computer, it's a kind of real world. I mean, it's a virtual world, but the illusion can be as powerful as computers allow. And the modern sort of computer games like Second Life.
Yeah.
Have you ever been in Second Life?
I'm afraid I haven't.
Well, I'm afraid I have.
What's your avatar look like?
A very nubile female. Total disguise. But nothing in Second Life evolves, but there's no reason why it shouldn't. I mean, all sorts of other things go on in Second Life. There's no reason why evolution shouldn't go on.
Yeah.
And so that, I think I find that immensely exciting. Other people don't, because they think it's unreal. They think it depends so heavily upon a man-made computer that but actually that's a trivial problem. It's not even interesting.